All right, so let's start hyperbola 13.3. So we didn't start at all last time? We did a little bit, yeah, but it's just really barely, right? Okay, so 13.3 is hyperbola. All right. Now, let's do more, and we will finish 13.4 today. 13.3 and 13.4. Oh, aren't you guys glad? And we have a test tomorrow, don't we? No, on Wednesday. Yes.
Thank you.
Okay. Okay. So this is number 1. So find the coordinates of the center, vertices, and asymptotes. All right. Good. Now, number 2, this one is not enough to do the homework. So, number 2, what about if I have 8 times y plus 3 square minus 2 times x minus 4 square is equal to 32? So, what are we going to do here? Yes, good. So, okay guys, Karen and Alex. So, what do we do now? We divide both sides by? You're right. So let's divide each one of them by 32. So, oh, I was going to use this. So divide by 32, divide by 32, divide by 32. Okay, so what do we have when we divide by 32? So 32 divided by 8, that is 4. So y plus 3 squared over 4 minus x minus 4 squared over, what is 32 divided by 2? 16. This is equal to 1. So this is in standard form of hyperbola, isn't it? Okay. Now, how do we know this is a hyperbola and not ellipse? Because the coefficient of x squared and y squared are opposite. Oh, sorry. Am I sharing my table? Okay, let me share. Share my desktop. Yeah. Because otherwise you hear my voice and then you can't see it. Yes. So yes, this is a hyperbola. And how do we know again that this is a hyperbola versus an ellipse? Yes, the coefficient of x squared and y squared are opposite signs. Yes. What type of hyperbola? Horizontal, vertical?
Horizontal.
No, it is vertical. Why is it vertical? Yeah, because y squared, right? Y squared have positive coefficient. Yes. Y squared has a positive coefficient. Is it? Yes. So what is the center of this hyperbola? Be careful. What is the center? No, it doesn't start with -3. Yes, it is 4, -3. So it's always x, y, remember? Okay, good. So it's always x, y, and that's why. So 4, -3, where is 4, -3? Okay. Good. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay, so x, y. So 4 comma negative 3 is right here. 4 comma negative 3. All right. So how many units do I go left and right? So what is A? A square is, so A is equal to B square is, so B is equal to, A square is 16, A is 4, so left and right we will go 4 units. B square is 4, B is 2. So left and right is 4. So the number under the x is 4. So left and right is 4. So 1, 2, 3, 4. And 1, 2, 3, 4. So this is 8 comma negative 3. And then this is 0 comma negative 3. Okay. And then how many units do we go up and down? 2. Yes. 2 up, 2 down. So this is 4 comma negative 1. Should be a little bit more up. And what about this? 4 comma negative 5? All right. Then what am I going to do? Draw the rectangle? Yes. All right. So draw the rectangle and then asymptotes. Yes. All right. Good. And then, so we connect the two opposite corners to draw the asymptotes. So those are your asymptotes. Now, what type of hyperbola do we have? Vertical. So I'm going to use these two vertices. So I could label my vertices. My vertices is 4 comma negative 1 and 4 comma negative 5. So you got to box this. This is being asked. And then the center also, you got to box this. This is being asked. And we will draw the hyperbola. So it looks like this. So it's actually not like a parabola, right? This is your hyperbola, y plus 3 squared over 4 minus x minus 4 squared over 16 is equal to 1. So this is your hyperbola. Okay. I'm missing something. I didn't answer something, which is what? Asymptotes? What are the equations of the asymptotes? Y is equal to plus or minus b over ax. But this is translated, isn't it? Is it shifted? Yes, the center is not 0, 0, so it's not y and x. This will be what? Y plus 3 and x minus 4. So this is your y plus 3, so we copy it here, and x minus 4 is here. So it's shifted. And what is b over a? So b over a is 2 over 4, right? 2 over 4 is what? 1/2, yes. That's it. 1 over 2, x minus 4. Do you have to solve for y? No, you don't. Leave it in this form. Yeah. Finish? Doable? Yes? Okay. Now, so first of all, do we know why it's a hyperbola and not ellipse? Second of all, do we know why this is a vertical hyperbola and not a horizontal hyperbola? Why is this a vertical hyperbola? The coefficient of y squared is positive. Yeah. That's why this is a vertical hyperbola. Yes? Mm-hmm. Yes. So for example, if your equation was, this is something else. X plus 2 squared over 9 minus y minus 3 squared over 16 is equal to 1. What type of hyperbola is it? Horizontal. And what is the center? Negative 2 comma positive 3. How many units do you go left and right? 3. How many units do you go up and down? Okay. Make sense? Okay. And then you draw the rectangle and the asymptotes and things like that. Yeah? Okay. Good. All right. Yes, you're right. Now, the other hyperbola is non-standard. So B is non-standard hyperbola. Non-standard form of hyperbola. Hyperbola. Okay, so this hyperbola that comes in next has an x-axis and y-axis as asymptote. When we say non-standard hyperbola, we have, so this is the equation of hyperbola having x and y axes as asymptotes. So it is of this form. xy is equal to k. So for example, maybe xy is equal to 4 or xy is equal to negative 4. Those are examples. Yeah. So the x and y axis are their asymptotes. So we're going to graph those. Okay. Yes? Okay. So xy is equal to 4. How are we going to graph xy is equal to 4? So graph xy is equal to 4. So then you have a table, right? Oh, by the way, can I rewrite this? Xy equals to 4. So y is 4 over x. Yes. So then we could have a table. All right. So this is x, this is y, which is equal to 4 over x. And that's xy is equal to 4. What x can I choose? What x? Negative 4, right? Negative 2, negative 1. What about 0? 4 divided by 0 is undefined. So you can't do 0, right? So it's just negative 4, negative 2, negative 1. So 4 divided by negative 4 is negative 1. 4 divided by negative 2 is negative 2. And then this is negative 4. 4, 2, 1. Isn't it? Okay. So let's graph it. Okay, here is enough, I think. So 1, 2, 3, 4. 1, 2, 3, 4. All right. Okay, negative 4 comma negative 1 is right here. Negative 2 comma negative 2 is right here. And then negative 1 comma negative 4 is right here. And then this is 1 comma 4. 2 comma 2. So 1 comma 4 is higher. 2 comma 2, and then 4 comma 1. Okay, so it's going to look like this. Alright, so this is your hyperbola xy equals to 4. So this is 4 comma 1, 2 comma 2, 1 comma 4. This is negative 4 comma negative 1, negative 2 comma negative 2, negative 1 comma negative 4. Do you see it? That it is the x-axis and the y-axis is the asymptote? Yes? Okay. Do you want to draw the other one? Xy equals negative 4? It's almost the same thing, but it's going to be here and here. Yeah, so maybe we don't need to do that, do we? So this one, xy equals negative 4, is going to be right here. Yeah, but same thing, the asymptotes are x-axis and the y-axis. Yes, so that's non-standard. Yeah. So when you see this, something like xy is equal to k, then you'll think, oh, yeah, that's a hyperbola too. But what? But what? It's non-standard. Yeah, why? How is it non-standard? The asymptotes will be x and y-axis. Doable? Okay. Now, the next thing is we're going to classify conics. So, classifying conics. So, this is where we're going to say, oh, this is a hyperbola. This is a parabola. This is a circle. This is an ellipse. Yeah. So, okay. So, so we're not going to talk about the degenerate terms, right? Okay. Let's see. So if we ignore the degenerate terms, so if conic exists, the conic exists, yes. So non-degenerate terms. So we have a graph. Then let's see. When do you have a parabola? Then we have a parabola when? We have a parabola when? How do you know that it's a parabola? Yes. If the equation contains, so you have to simplify each equation, right? Either x squared or y squared, but not both. Right? It's either x squared or y squared, but not both. If conic exists, meaning excluding the degenerate cases. So if the equation contains either x squared or y squared, but not both. Yeah. Now, when is it an ellipse? When? So whenever if conic exists, so we're excluding degenerate cases. When is it an ellipse? If coefficient of x squared and y squared have both positive signs, have the same signs. Have the same signs. So same signs mean can be both positive or both negative. But then, remember, you have to change it to standard form, right? So when you divide, same signs, either both positive or both negative. When do you have a circle? So if the coefficient of x squared is equal to, well, maybe let me just write equal sign, maybe better for you. Exactly the same, coefficient of y squared. Right? Now, number 4, when is it a hyperbola? When is it a hyperbola? How can we say, oh, this equation is a hyperbola? Yes. If the coefficient of x squared and y squared are of opposite sign. Okay. All right. Yes? Doable? Okay. Good. And also you have a non-standard, right? Also, you can recognize the non-standard. Also the non-standard. When we have xy is equal to k. So just remember that's the non-standard. Now, let's classify conics. Yeah. You guys ready? Yeah. Yeah. So, for example, classify each conic. So, number 1. 1 plus 3y is equal to 2y squared minus x. 2. 3x squared plus 5y squared plus x squared is y squared plus 49. Number 3. 16x squared plus 5y squared minus 12x squared plus 8y squared minus 3x plus 4y is 568. And then number 4, let's see. 3x squared plus y squared minus x is equal to 2x squared minus 9x plus 10y plus 40. Alright, so what would you do first? So number 1, is it obvious or not? Okay, so what's the answer to number 1? Parabola? Why? Only y squared, not x squared, so it cannot be ellipse. You don't have to write down the reason, okay? So you can, as long as you know it's parabola, it's good. Now, what about number 2? What would you do first here? Do you want to put everything on the left? So this is 4x squared plus 4y squared is equal to 49. So why is it circle? Coefficient of x squared is equal to coefficient of y squared. Yes, that's right. How about number 3? Is it a circle too? Huh? Is it? 16x squared minus 12x squared, that is what? 4x squared plus y squared. What about y squared? 13y squared, right? And then minus 3x plus 4y minus 568 equals 0. So what is this? What type of conic? Why is it ellipse? Which one? Wait, I mean, we only have 4, right? And then I'm asking you, what type of conic is this? Ellipse? Why is it ellipse? Yes, because coefficient of x squared and coefficient of y squared are of the same sign. Yay or nay? What about the last one? So this is, what is this? So is this x squared plus y squared? So we subtract everything, right? And then minus plus 8x minus 10y minus 40 equals 0. So what type of equation is this? What equation is this? Ellipse? Why is it an ellipse? Well, but aren't they exactly the same? Yeah. So what is this? This is a circle. Yes. A circle. Yeah. A circle is a special type of ellipse, right? Why is it a circle? So coefficient of x squared is equal to coefficient of y squared. Alright. Yes? Doable? Yeah. Yeah, this is an ellipse, but a circle is special type of ellipse. So the most appropriate one is to answer that this is a circle. Okay. I'm waiting for questions. No? Okay, so I still have to keep waiting? What about these? Can you give me answers? Yes, good. Okay, good. So now I'm done with 13.3. What did we do in 13.3? Math, I know. What type of math? Hyperbola, so, and classifying conics, and one more? The non-standard ones, yes. The one with x and y axis as asymptotes. So, is it doable? Okay, good. So, let's talk about 13.4. Math 125, yes. All right. Save. Yes. Good. So this is hyperbola. So, did I just lose it? Let me see. Did I just lose my notes? Yeah, I got tired of these two. You know, I always lose my notes. Where is the recent one? Where is that? Where is my notes? What happened? 13.3 is hyperbolas, right? But which one? I mean, this is so many. The top one? Okay, good. Let me see. Oh, yeah, that's right. Yes. Okay, good. File, save as, save as. 13.3 hyperbolas. Save. Yes. All right. So now this one has everything. Yeah, good. That's what I want, right? Thank you. Now, let's talk about 13.4. So we're actually done with hyperbolas, and 13.4 is substitution elimination. Yeah. So it will be substitution and elimination. So I'm pretty sure this one is not too difficult for you. I hope not. Yes. What's disturbing? This one? No. Oh, if it's hard, well, it's a little bit different because it's non-linear, so you have to check. But other than that, then you should be fine. Yeah. So 15.4 is non-linear systems of equations. So we will use either substitutions or elimination. Yeah. So substitution or elimination. So we know what they are, right? Now the difference is for here is check the solution by substituting to both equations. Right. So that's it. That's what you need to do. And there is a shortcut later on. Then I will tell you the shortcut. Yeah. So you don't have to check to both, but only one. But you got to choose accordingly. All right. So now let's see. So nonlinear system of equations. So it looks like this. Okay. So for example, all right. So for example, let's see. We have solved and write the solution as ordered pair. The solution as ordered pair. Yes. So number one. X squared plus y squared is equal to 41. And then y minus x is equal to 1. So this is equation 1. This is equation 2. All right. So we will use either elimination or substitution. Do you think we could use elimination? Not really. Do I have x squared on second equation? No, I don't. Do I have y squared on second equation? No. So I need to use substitution, right? How do you think you'll use the substitution here? Solve for what? Solve for y in equation 2. Okay. So when we solve for y, what do we have? When we solve for y, what do we have? Y is equal to x plus 1. And this is equation 3. So regular substitution. Have you seen this before? Sort of, right? Yes. Okay, and then what do you do? Yes, so substitute y equals x plus 1 to equation 1. So when we substitute, then we will have x squared plus x plus 1 squared is 41. All right, so what will this be? What will this be? Yeah. What will this be? X squared plus x squared plus, oh, this is x plus 1, x plus 1. So you could do that first if you want. X plus 1 is 41. So then we'll have x squared plus 2x plus 1 is 41. All right. Then what do we have? 2x squared plus 2x, and then minus 40 is equal to 0. So you subtract 41 from both sides, because this is quadratic equation, so one side must equal to 0. Okay, so what next? Divide by 2, so what do we have? X squared plus x minus 20 is equal to 0. Okay, so can we factor it out? X plus 5, x minus 4 is 0. So x is negative 5 or x is 4. All right. Are we done? Yeah, you have to write down the ordered pair, right? Okay, this is only x. So, what do? You have to find the y, don't you? Okay, so substitute to equation 3. 3 is the easiest one. So when x is negative 5, what happens? When x is 4, what happens? Y is equal to negative 5 plus 1. What is negative 5 plus 1? Yes. So when x is 4, y is 4 plus 1, which is 5. Okay, so what are my solutions in ordered pair? Oh, then I have to check. So this one is negative 5 comma negative 4, and this one is 4 comma 5. Yes. And then you got to check. Yeah. Now, which one did we use to get the y? Is it equation 3? Yeah. So we don't have to check again with equation 3 because we used it to get the y. So we just need to check with equation 1, right? No, because 2 and 3 is the same. 2 and 3 is the same, so you just check equation 1. Is it true when you check? So 25 plus 16 is 41, and then 16 plus 25 is 41? Yes. So both are solution. All right. Why do you have the solutions? What happened here? Well, if you think about it, if my equation is x squared plus y squared equals 41, then what would that be? What type of conic is x squared plus y squared equals 41? A circle. Yes. So you sort of have a circle. Oh, what am I doing? Hold on. I was going to draw a circle. Good. This is a circle. Now, what about the second equation? What type of, well, this is not a conic, I guess, right? What is this? Y equals x plus 1. If I graph it, what would that be? A line, yes. So if I graph it, then it probably looks like this, right? Or maybe not. Y equals x plus 1 is, I don't know, maybe it looks like this. Yeah. And how many times does it intersect? Twice. So that's why it has two intersections. One is -5, -4. The other one is 4,5. So you could sort of think about this. This is 4,5. Maybe this one is -5, -4, somewhere here. Make sense? Yeah. So there are a lot of possibilities. So you could have a circle that doesn't intersect. So this one has no solution. And you can have a circle with one intersection. Yeah. What happened? Yeah, tangent. So it intersects only at one point. Or this one, the thing that we just did, the equation that we just did, has two solutions. So so it can have two solutions. Does that make sense? Do you have to graph this? Not really, as long as you know you find the solutions. Yeah? Doable? Okay, yeah, it's not that hard. Let's do more. Yeah? Should we do the one with the elimination first? Yeah, let's see which one is elimination. The elimination's not that hard either. So it looks something like, let me see which elimination is a little bit harder. Oh, they're not hard. Okay, so this one has a, it's not that hard. Okay, well, let's just do it, even though it's not hard. Yeah. What about if we have 2xy plus 3y squared is equal to 7, and then 3xy minus 2y squared is equal to 4. Oh, by the way, today I'm supposed to go to doctor at 2. So my office hours, usually I have lunch break. I don't have office hours between 1:30 to 2:30, so I'm changing it today to 1:30 to 2:30. So I will be in my office time after this class up to 1:30. Yeah? So just today only, because usually I don't have office hours 12:15 till 1:30 or 1:45. Yeah. And then I have 1:45 till 3:30. But I will have to go out early today. So I will exchange my lunch break. But you guys never come anyway, right? Okay. All right. So this is equation 1, equation 2. It said when you come, I want you to find these and then say, oh, Mr. Siswanto is never at the office. All right. So anyway, what would you do here? Think about it. Would you eliminate? Which one? XY, right? Because if you eliminate XY, then you could solve for y squared and then y. Yeah. Good. Now, how do you eliminate XY? Yes. Eliminate XY. So, equation 1, we will multiply by 3? Yes. So 6xy plus 9y squared is 21. Equation 2, we multiply by -2. So what? -6xy plus 4y squared is equal to -8. Yes. So we add 13y squared is equal to 13. So y squared is 1. What is y? No. Plus or minus 1. Right? Remember the plus or minus, because otherwise you're missing a solution. Yeah. Okay, so you have two y's. Then what do you do here? Substitute to equation, which equation? 1? Yes, it's the same heart, right? So when y is 1, so you have to answer, so you have to substitute it 2 times. When one is when y is 1, the other one is when y is -1. When y is 1, what do you have? 6x times 1 plus 9 is equal to 21. Okay. So 6x is equal to what? 21 minus 9 is 12. So x is 2. All right. So here we have 2, 1. Then we have to check later. Yeah. What do you think I'll do next? Yes. Y is -1. So 6 times -1 plus 9, it's still 1, is equal to 21. Oh, x. I'm forgetting the x. So -6x plus 9 is 21. Then what? -6x is 12. What is x? -2. Yes. Good. So what is this? -2, -1? All right. I wonder why I just didn't do it up there. Yeah. Okay. -2, -1. What do I do now? We check. To which one? Which one do you check? Equation 2. Why? When you solve for y, it's equation 1. So you could just check it on your head, right? Or you could write it. So what's the x 2, 1? 3 times 2 times 1. So this is 2, 1. You're checking 2, 1. So 3 times 2 times 1 minus 2 times 2. Is it equal to 4? Yes or no? Did I do it wrong? Oh, minus 2 times 1. Sorry. Y is 1. True? So 2, 1 is the solution. Yeah. That's it. Now what? -2, -1. So 3 times -2 times -1 minus 2 times 1. Is it 4? Six minus 2 is 4? Yeah, true? Okay, good. So what are my solutions? Yeah, -2, -1, and 2, 1. All right. Yes, Brandon? Which one? This is -1 square. Yeah, it's -2y square. This one, this is a square. Yeah. So what is -1 square? Yes. -1 square is 1. Yeah, good question. Yeah. Yes, Frank. You substitute to equation 1. What was equation 1? Yeah. 2 times x plus... Oh! So this is supposed to be 2? Wait, no. How do I get 6, right? Is that what you're asking me? Okay, let me see. Is this correct? Am I doing it correct? Okay, wait. Okay, is this is correct so far up to here, right? And then what about this? This is wrong? No, it's not? Oh, I see what you're saying. I'm using this equation. I see. No, I'm supposed to use this equation 1. Yes, you're right. So I am supposed to use this equation 1, not this. Should I change it? Same answer, yeah. Yeah, it will be the same answer. So if I were to use, I'm sorry, I think my eyes are blind now. So if I'm using this one, you'll see. So this is what I'm supposed to do, okay? So this is 2 times x times 1 plus 3 times 1 is equal to 7. So 2x plus 3 is 7. So 2x is 4. So x is equal to 2. So it's the same answer, yeah. Yeah. Sorry. Yes, yes. Mm-hmm. Which one? You're talking about this one? This is going to be positive 6, right? And then this is minus 2. And should that be negative 4? No, this is 2 times negative 1 squared. So this one is 1. Yeah. I'm sorry, what I did was I thought this is your first equation. That's why I messed up there. That's why when I substitute to this equation instead of the regular equation 1. Yeah. Should I redo them? I could redo them. No, but you guys get the idea? Yeah. Oh, okay. Okay. Yes. Right. 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 Yes. Yes. Okay. Are we okay so far? Yeah. You're doing good. So we have 4 minutes. Should we do one more? Let's look at sample test. So tomorrow you guys are gonna do sample test, right? Or just tomorrow? Yeah. Yeah. So tomorrow 2 things. Bring chapter 13 sample test and Wednesday 4. Yes, there's only 4. We're done with chapter 13. That's it. Nothing else. Yeah? Yes. On Thursday, I'm going to tell you the SLO that I will put on the final exam. Yeah? Yes. So I think, okay guys. So tomorrow we will discuss chapter 13 sample test until we're done and then discuss the final sample test. So you have to bring how many sample tests? Yes, chapter 13 and final. Yeah. Final is when? On Tuesday, right? Tuesday, 9:30 to 11:30, this room. No, there's no class on Monday. No class Monday? No. You only come during the final week. You only come on that day. Yeah, and then, yes. So one more test and then final. So you think you'll do well, chapter 13? Yes. Okay. Oh yeah, I'm going to give you back your exams. All right. So let's see. I'm done with 13.4. So yeah. So that's it. We're done with the material. Yay! Thank you guys. It was a good class.